Alright, so in this video, we're going to go through sample question 63 from the Society of Actuaries ExamP list of sample questions. Some of the more astute of you might notice I've already had a go at this question. I didn't like my initial explanation. I'm re-recording this, so you didn't miss anything here. Alright, so the question reads, the warranty on a machine specifies that it'll be replaced at failure or age 4, whichever comes first. The machine's age at failure is x and has a density function, follows here, 1/5, between the values of 0 to 5 and 0 otherwise. Let y be the age of the machine at the time of replacement. We need to calculate the variance of y. All right, so we have two things here. We have x, which is the time that a machine fails, and y, which is the age of the machine at the time of replacement, which happens to be a function of x. All right, so let me first figure out what y should be. The density function of y should be as follows. So y is going to be equal to, it's going to be piecewise, right? The time at replacement will be x, right? As long as it fails between 0 and 4 years. 0 to 4. And we know that because of this statement up here, it will be replaced at failure or at age 4, right? Whichever comes first. So that means if there's any point over 4 years, right, it can't fail at a negative year, right, before it actually starts being used. It must be replaced at 4. And this is going to occur from 4 to 5. And we know that 5 is our upper limit because of this part right here. All right, because the machine will fail from time 0 to 5, no time outside of that, based on what we're given. So now what does the question ask of us? It asks to calculate the variance of y. This should be, once we've set this up, this becomes a very straightforward calculate the variance of a continuous distribution. A formula you should be very familiar with is right here. Variance of y is equal to the expected value of y squared minus e of y, right? Expected value of y. Oh, expected value of y squared. So how do we actually get these expected values, right? So this essentially boils down to, we need the expected value of y, we need the expected value of y squared. The expected value for a continuous distribution is the integral over the specific interval of x multiplied by the PDF, all right, of whatever's inside multiplied by the PDF. So let me go about actually computing that. First, the expected value of y. That should be equal to, so I'm going to integrate, and this comes in two places, 0 to 4, right? And the thing that's going in there is x multiplied by 1/5 dx plus, and then next I'm going 4 to 5, and that's the integral from 4 to 5, 1/5 multiplied by 4 dx. And I've already had this done out from the first time I had to go with this. Again, just did not like my explanation. This will become 10x squared, evaluated from 0 to 4, plus 4 over 5 x, evaluated from 4 to 5. Evaluating these, you could use your normal graphing calculator. You would get these numbers. 16 over 10 plus 20 over 5 minus 16 over 5. And you end up equaling 12 over 5. And that is the expected value of y. Similarly, we can get the expected value of x. Okay, so, sorry, not the expected value of x, the expected value of the second moment, y squared. Well, actually, it would just be called the second moment, not the expected value of the second moment. You know, you just should get my meaning. So I'm integrating from 0 to 4, and it's the second moment, so it's going to be 1 over 5x squared dx. And I didn't mention I'm getting the 1 over 5 from here, from the original density function of x. And then that is added with integral from 4 to 5. It's going to be 1 over 5 multiplied by 4 squared, 16. And yeah, and that is dx, right? Got it. And evaluating that ends up being 1 over 15x to the third, 0 to 4, plus 16 over 5 times x, and that is 4 to 5. All right, and this ends up computing to 64 over 15 plus 80 over 5 minus 64 over 5, which equals 112 over 15. And that's our second moment. So substituting into these equations, we get 112 over 15 minus, what was it? 12 over 5. 12 over 5 squared. And all you need to do is plug this into your calculator to get approximately 1.71, lines up with answer choice C. Okay, so pretty straightforward variance problem with continuous random variables. Just a brief overview. What we first had to do is identify, okay, what are x and what's y? Then what is the density function of y? Because that is a function of x. Once we got the density function of y, in order to get the variance, that requires getting the first moment and second moment. In order to get expected values with a continuous distribution, you must integrate, right, this value multiplied by the actual PDF, like whatever's in here, multiplied by the PDF. And that's pretty much it. That'll get you variance. If there are any questions, feel free to leave it in the comments. I'll answer to the best of my abilities as quick as possible. If you want to see more videos like this, I got a playlist, right? Sample ExamP questions. And if this video helps you out, hit the like button, subscribe, because that totally helps me out. That's what's going to keep me making more of these. All right, but other than that, good luck.